Determine the equations of horizontal asymptotes repeatedly. Okay. Well, you know the drill for each of these. We take the highest power of x that we can find in the expression and divide everything by it. So, for this first one, we have x squared over x cubed minus 4. The highest power is 3, so we're going to divide everything by x to the 3. We divide the numerator by x to the 3. We divide both pieces of the denominator by x to the 3, and you can do this in your head pretty easily if you've had a little practice. What you end up with is the limit as x goes to plus or minus infinity of, up top we get 1 over x squared. Sorry, just 1 over x. Downstairs we get 1 minus 4 over x cubed. And we know that whenever you have a constant divided by a power of x and x goes to infinity, that constant just vanishes, or that quotient just vanishes. So the 1 over x just goes to 0. The 1 survives, and then we get minus 4 over x cubed. And so our limit for this is 0 over 1, which is plain old 0. So the horizontal asymptote for this thing would be at y equals 0. Here, highest power is x squared, so if we divide everything by x squared, we're going to get 2 minus 1 over x for our numerator. Downstairs, if we divide by x squared, we get 4 minus 3 over x squared. Limit as x goes to infinity. So if x goes to infinity, these two terms are going to vanish, and we get 2 over 4, which of course reduces to 1/2. Here, highest power is x to the 3, so divide everything by that, and we get minus 5 minus 4 over x. And downstairs we have 3 over x plus 1 over x squared. Limit. All the things divided by x vanish, and we get minus 5 over 0, which means the limit does not exist. If the limit doesn't exist, it means the horizontal asymptote does not exist. And we could have seen that coming because here we had the degree of our numerator greater than the degree of the denominator. That means this function is going to increase forever. It's never going to flatten out. This will have a slant asymptote, but it will not have a horizontal asymptote. And finally, highest power here is x to the 3, so if we divide by that, we get limit as x goes to infinity, minus 4 plus. Here's what these look like when you've had some practice. Minus 4 plus some small stuff that doesn't matter over 6 plus some small stuff that doesn't matter equals minus 2/3. We know that the highest power terms in each of these are going to dominate and everything else will become too small to matter, so really we're just paying attention to these first, or the highest degree terms. That brings up a small point. I almost said the first term here, but one of the ways we can try to get you with these questions is to give these in the wrong order. If we do, let's say, I'm making this up, minus 5x plus 7 over minus x plus 6x squared plus 12. If you're not careful, you'll look at these leading terms and say minus 5 over minus 1, the horizontal asymptote at 5. But that's not what's really happening. The highest power in this is actually x to the 2, and you can overlook this if you're not paying attention if we put these out of order. It's kind of a dirty trick, but it is something we could throw at you, and I don't want you to get caught by it. So please don't assume that the first term is the highest power term. It should be. That's how I encourage you to write them, but we can mess with you by switching up the order. Scan carefully, make sure you've really found the highest degree, and divide everything by that. If you divided everything in here by x to the 2, you'd come up with 0 over 6, and that would tell you that we have a horizontal asymptote at 0. With this one, everything was in the proper order, so it was okay for me to just do minus 4 over 6, but make sure you don't get caught, please.